Vidvas Learning is a product of Vidvas Technologies Private Limited. In this session, we would go over 5G Core Overview. The following is the list of widely used abbreviations in 5G Core. The diagram shows various 5G use cases. Let us go one by one. Enhanced mobile broadband use case. The 5G standard promises to usher in the next era of immersive and cloud-connected experiences with faster, more uniform data rates at lower latency and lower cost per bit. The 5G standard will take mobile computing performance to the next level with high speed, always on, always connected internet links with real-time responsiveness. This category includes virtual reality or VR and augmented reality or AR experiences. Next use case, EV2X. This includes vehicle platooning, automated driving, extended sensors and remote driving. Next use case, massive MTC. One of the most anticipated 5G use cases is the ability to seamlessly connect embedded sensors in virtually everything. The industry foresees huge numbers, as many as 50 billion, of potential IoT devices in service by 2020. Industrial IoT is one area where 5G will play a major role, from smart cities to asset tracking, to smart utilities, to agriculture. Next use case, network operation. The high reliability and low latency of 5G unlocks the ability to control critical services and infrastructure. This creates new opportunities for public safety, government, city management and utility companies. Next use case, critical communication. This category includes new services that will transform industries with ultra-reliable or available low-latency links, such as remote control of critical infrastructure and self-driving vehicles. The level of reliability and latency will be vital to smart grid control, industrial automation, robotics, drone control and coordination, and so on. This is the list of network functions available in 5G Core. We would explore a few network functions in detail in upcoming slides. Let us go over service-based representation of 5G Core. In this slide, we would briefly discuss important network elements of 5G Core, along with architecture. 5G Core architecture has changed dramatically, for all good reasons. Network slice plays vital role in 5G. Based on type of service, UE requests, a network slice is assigned to UE. If you would like to know more about network slice, please go over Vidvas Learning video tutorial. Here, UE is user equipment. RAN is radio access network. This is 5G radio, similar to ENB in LTE network. AMF is the access and mobility management function. In LTE, mobility management and session management is handled by MME. In 5G Core, mobility management is handled by AMF. SMF is the session management function. In 5G Core, session management is handled by SMF. In LTE, during attach procedure, UE would register with LTE network and can get IP address in a single step. In 5G Core, it happens in two steps. UE registers with 5G network in step 1, and UE requests PDU session in step 2. This is similar to 3G. IoT devices don't need PDU session or IP address. As 5G Core needs to support massive number of IoT devices, these devices need just registration. So, IoT devices may not need SMF. AMF is good enough for 5G registrations in case of IoT devices. Authentication and subscription management functions of LTE are distributed across OSF and UDM. OSF is the authentication server function. OSF supports authentication for 3GPP access and untrusted non-3GPP access. UDM is the unified data management. UDM handles mainly subscription management. UPF is user plane function. UPF is anchor point for intra or inter-rack mobility. It supports external PDU session point of interconnect to data network. DN is data network. For example, operator services, internet access or third-party services. In 5G Core, AMF can be considered as the combination of S1AP, mobility management part of NAS, and partial S6A handling of LTE, MME. SMF can be considered as the combination of session management part of NAS, partial S6A, SGW control plane, PGW control plane functionalities of LTE, EPC. UPF can be considered as the combination of SGW user plane and PGW user plane functionalities. OSF can be considered as AUC functionality of LTE, HSS. UDM can be considered as subscription handling of LTE, HSS. PCF can be considered as PCRF of LTE, EPC. DN can be considered as PDN connection of LTE. AMF, SMF service-based interface towards north side. The horizontal line above AMF and SMF shows service-based communication in 5G core. Let us go over AMF. AMF is the access and mobility management function. AMF includes the following functionality. Some or all of the AMF functionalities may be supported in a single instance of an AMF. Termination of RAN control plane interface, which is N2. Termination of NAS, which is N1. NAS ciphering and integrity protection. Registration management. Connection management. Reachability management. Mobility management. Lawful intercept. Provide transport for session management messages between UE and SMF. Transparent proxy for routing session management messages. Access authenticate. Access authorization. Provide transport for SMS messages between UE and SMSF. SMSF is SMS function. Security anchor functionality. Location services management for regulatory services. Provide transport for location services messages between UE and LMF, as well as between RAN and LMF. LMF is location management function. EPS bearer ID allocation, for interworking with EPS. UE mobility event notification. Let us go over SMF. SMF is the session management function. SMF includes the following functionality. Some or all of the SMF functionalities may be supported in a single instance of SMF. Session management deals with session establishment, modify and release. UE IP address allocation and management. DHCP-v4 server and client and DHCP-v6 server and client functions. ARP proxying. IPv6 neighbor solicitation proxying. The SMF responds to the ARP and/or the IPv6 neighbor solicitation request by providing the MAC address corresponding to the IP address sent in the request. Selection and control of user plane function, including controlling the UPF to proxy ARP or IPv6 neighbor discovery, or to forward all ARP IPv6 neighbor solicitation traffic to the SMF for Ethernet PDU sessions. Configures traffic steering at UPF to route traffic to proper destination. Termination of interfaces towards policy control functions. Lawful intercept. Charging data collection and support of charging interfaces. Control and coordination of charging data collection at UPF. Termination of session management parts of NAS messages. Downlink data notification. Initiator of unspecific SM information sent via AMF over N2 to access network. Determine SSC mode of a session. SSC is session and service continuity. Roaming functionality. Let us go over UPF. UPF is user plane function. UPF includes the following functionality. Some or all of the UPF functionalities may be supported in a single instance of a UPF. Anchor point for intra or inter-rack mobility. External PDU session point of interconnect to data network. Packet routing and forwarding. For example, support of uplink classifier to route traffic flows to an instance of a data network. Support of branching point to support multi-homed PDU session. Packet inspection. For example, application detection based on service data flow template and the optional P received from the SMF in addition. User plane part of policy rule enforcement. For example, gating, redirection, traffic steering. Lawful intercept. Traffic usage reporting. QoS handling for user plane. For example, uplink or downlink rate enforcement, reflective QoS marking, in downlink. Uplink traffic verification. For example, SDF to QoS flow mapping. Transport level packet marking, in the uplink and downlink. Downlink packet buffering, and downlink data notification triggering. Sending and forwarding of one or more, end marker to the source NG RAN node. ARP proxying. Let us go over UDM. UDM is the Unified Data Management. UDM includes support for the following functionality: generation of 3GPP aka authentication credentials, user identification handling. For example, storage and management of SUPI for each subscriber in the 5G system. SUPI is Subscriber Permanent Identifier. Support of the concealment of privacy-protected subscription identifier. Access authorization based on subscription data. For example, roaming restrictions. UE serving network function registration management. For example, storing serving AMF for UE, and storing serving SMF for UE-PDU session. Support to service or session continuity. For example, by keeping SMF or DNN assignment of ongoing sessions. Mobile terminated SMS delivery support. Lawful intercept functionality. Subscription management. SMS management. The following diagram is reference point representation of 5G core. We may not discuss more here, as service-based representation is more desired. Here, we discuss QoS flows mapping in 5G core. QoS Flow Index or QFI is newly introduced in 5G. In LTE, QoS enforcement is done at bearer level. In 5G core, QoS enforcement is done at flow level. We would go over QoS details in other videos. Registration management has two states: RMD registered, RM registered. This is similar to LTE. Connection management has two states: CM idle, CM connected. This is similar to LTE. The following is the list of 3GPP, IETF, Open API references. The following is the list of Stage 3 specifications, for respective services and APIs. For upcoming videos, please subscribe to Vidvas Learning channel on YouTube. For complete set of videos on 5G core, please contact us at vidvaslearning@gmail.com. To know more about Vidvas Technologies Private Limited, please visit our website www.vidvas.com. Thank you for watching.